So just a little bit of an introduction into me. My career has been as a software engineer. A good part of my career I spent as the engineer on data science or science teams. Around 2011, when data was the new oil, or data is the new oil, was exploding as a term. Lots of companies over-indexed on hiring lots of data scientists. And then once they got to the first few products, they realized they didn't have anyone kind of sucker enough to run this stuff in production. And they came and found engineers like me to join the team. And there's like a really common term in poker, not like play poker, that if you're sitting around a poker table and after about 15 minutes you can't tell who the patsy is, it's you. And I say it's like a very similar thing. If you're sitting on a team of data scientists or machine learning researchers, and you can't figure out who the person who's going to be on call with the pager for these services is, it's you. This is a nice surprise you'll get, but that's that. And then, yeah, the great thing about being on data science teams was I was exposed to proper science, and it really influenced my kind of work as a software engineer going forward. And then later on in my career, or most recently, I described it that I accidentally fell into a leadership gulch. What that means is I was CTO of a small startup, which generally means you're just the primary engineer, but accidentally got very successful, and suddenly I was executive at a company that did $1 billion in revenue. This is being recorded, so it was the most amazing thing that ever happened to me. That's that. And just right now, because as I described, if you can't tell who the patsy is, I've now gone back to the beginning. I'm currently founder and CEO of a company called Fuzzbox. We make a suite of software products that allow you to design, operate, orchestrate, validate, and measure infrastructure-based experiments. So if you're running stuff in production at serious scale and you are actually changing that software, you should have a chat. And if you're running stuff in scale and making money and you don't have to change that software, we should have a chat. How did you do that? You don't have to do any more work, because that's amazing. So yeah, just like to try and scope what we're talking about in this talk. Generally I'm talking to rooms of people who are production engineers, SREs, or DevOps people, and they're the type of audience that's covered in scar tissue and covered in battle armor, and we can talk about all the things that have gone wrong. And usually I'm there at the conference, I'm coming back from riding north of the wall and I have this story to tell you. There's these new types of services that don't behave at all like anything we've ever experienced, and it's going to get way worse. But just as a show of hands, how many of you consider yourselves practitioners, meaning you're a machine learning engineer, or maybe you're a scientist and you're actually creating work and doing that? And then keep your hand in the air if you're responsible for running any of this stuff in production, i.e. you get the call if it goes down or is broken. Okay, so not many of you. So this will be slightly different to how I present it to everyone else. So everyone else, I'm like, the data scientists are coming, and everyone like freaks out. But what I guess for you, this is more about, oh, this fell off. Maybe this will communicate some empathy for the people that do actually run and operate the services for you. So really, this is the gist of what we're talking about, and it's really models in production. And I realize now that, yeah, I'm coming at it as someone who isn't a scientist, but that's how we think about it as operators of systems that run in production. Like, you guys create all these models, and we have to get them into production. The other part we're talking about is outages, meaning that there was some behavior that was expected for how this should operate, and that was not happening. Either it was completely down, not working, or, as we'll go into, it was up and not quite doing the correct thing. And then in the final part of the talk, I just want to bring some concepts that are emerging from the field of SRE and production engineering, kind of expose you to them for how we should be thinking about operating machine learning at scale, and kind of give you a vocabulary for thinking about how to do that. And maybe it's what you can ask the people who are on call, which is none of you, which is wonderful. Good job, everyone. So when we're talking about running things in production, there's really one primary measure, and it's availability. That's what we're all aiming for, is this thing that I operate and put in production available? And there's really and here's where you see my slide got messed up. There's really two threats to your availability. One is that you've changed the software, and the other is that the environment in which the software itself has changed and if software has stayed the same. So for us, we're talking about, oh, they gave me a laser, look, whoa. We're talking about this first one, you changing the software. That's the primary thing we're kind of addressing today. This is another talk. We'll talk about that, but we'll touch on it later. So traditional services, let's pull one out of thin air, a payment service. If it's experiencing an incident and something is going wrong, it experiences okay, let's see, I'm into the laser now I've used it. There's like very traditional characteristics of an incident. It's slow, it's down, meaning it's unavailable, you can't make requests to it, or it's coming up and down, it's flapping as we call it. And then there's these last two that are interesting. Or there's this other thing, which is when you kind of jump in and you have an incident, which is it's doing something weird, or it's making something else do something weird. And that's kind of the exciting part, is like things got weird, you have to investigate. But really, the gist is these first three, they're very clear, they're very simple to reason about. So, we can understand that, like, it's down. I can't make a request to it. Simple. We need to make it come up. Great, that's how we fix this issue. And a lot of the ways that we instrument these services for observability are like very well known. We have like really common metrics, like request rate, saturation, duration of requests. Like, these are things we know, and if we can instrument services, whether you have or haven't, you can understand whether they're up or down. Simple. This is how we do things. This is how we operate services. But when you're putting up data products into production, this completely changes. Oh, before we run ahead, this is really the gist of it. When you're learning about an incident while it's happening, you're learning about what's happening while it's happening, right? So a payment service, let's use the example of the payment service I pulled out of thin air. The business is no longer collecting money, the broken service is in production, an incident happens, we create a war room, engineers who are on call drop on or pop on, start debugging the issue, and while it's running in its broken state, we learn about it and we fix it, ideally. This is what usually happens. It's in process of the time of the incident, we learn about what the issue was, and then you have a post-mortem, a root cause analysis, figure out what's going on. So what's different about a machine learning incident? And this is where it gets really interesting, and everyone in the SRE room, if I'm talking to them, just like balks. So we said the first one's about it's unavailable, down, it's slower. With machine learning services, and we'll get into some incidents later, this is actually what happens. You can roll out like a busted model, and your response times get faster. That's weird, but it's still having an outage. Or it's more available in some sense, or it's more stable. So this makes everything completely different to reason about. But really, what then gets super exciting in a different way is these last two stay the same. But things get really weird. So all you're left, so just to touch again on the first, you can't really instrument for these first three. Because someone could optimize the model and it gets faster, or someone could break a model and it gets faster. So what do you allow? Like, how do you do any like automated remediation or anything like that? You can't. Actually, it makes it impossible to detect, because your traditional success metrics go completely out the window, because a broken case and an improving case look exactly the same. So we're left in this situation. It's completely difficult to reason about, almost impossible to debug. And most of the approaches that we take towards observability, yes, they're still valid for measuring it, but there's this whole other vector of failure that is now in existence. And this is really the gist of it. Before where I was saying you learn about the incident and you learn about the failure mode while it's happening, with machine learning and data products, this all completely goes out the window. In most cases, you want to just actually roll back, and then it may be completely impossible to figure out what went wrong. And there's one key reason for this, and I mentioned earlier there was this new vector of behavior. And I call this behavioral outages, where the service is up, running, but it's still out because of, and it's this key thing that we're all here for today. I tried to do this like Batman, data, replaces code. It didn't work. But yeah, data replaces code, and this is what makes machine learning services so interesting, and especially for someone like me who's not a scientist but loves just operating things at scale. Suddenly, the actual way that all this software and all these systems behave has a vector of behavior that comes from data. And that's completely interesting, because you can't really unit test it up front. And we had a few talks earlier about bias, but how do you prepare for that? Like, it's only in production that this sort of thing becomes visible to you as an operator. And again, we all know that more data trumps better algorithms, so this is only becoming more of a problem or a benefit. It's kind of like leverage works both ways, So the data can help you create these magical things, but it also makes you susceptible to these highly complex and difficult to reason about incidents. So I'm just going to go through a few incidents that kind of outline some of these things that happen in putting machine learning into production. And I've removed all mention of any companies and what went wrong. And if this wasn't being filmed, I might like give you some hints to what they are. But if I do that and it's on video, like you get lawyers. I don't like that. But lawyers are wonderful video. I love them. But just not today. So yeah, the first instance is like, let's think about this, it's stable. So this is concept in machine learning, which is like you have a pipeline jungle. So there's all these kind of like really complicated ETL process and types of data that come in, and then it produces your build artifact at the very end, and that's what you deploy. So in this incident, there was stale data being used, so actually nothing changed. So let's consider this was like a recommendation engine that was running on an e-commerce website. So essentially, a lot of the clickstream data that was coming through to update for the customers was not coming through. So this pipeline jungle was running, and somewhere along the line, there was a unrelated team that was meant to deliver this updated clickstream data, and it just wasn't happening for months. And what was happening? Stale requests or stale recommendations. Completely impossible to detect because it's completely tailored and personalized to different users. So you go on and you're like, yeah, that looks great, but the way to measure and detect this over time is like really difficult because how do you measure that recommendations aren't converting very well? Like how would you do it? Like it takes time. So it really starts to appear on a KPI report after at best a month, and it might take months for that to realize that you're churning customers and not retaining them. It's really difficult to reason about, and it's really difficult to detect because you can't actually just look at the data and be like, oh yeah, this segment of our population, their clickstream wasn't coming through. Easy, let's just quickly do that. Like this takes a lot of kind of forensics to dig through the pipeline there. Let's go into another one of it's faster. So again, this was deployed. All response times got faster, rousing success. All the dashboards all the operators had on the walls showed that response times went down. Everyone went home at the weekend. It was wonderful. But what actually happened is that there was like some poor training data, and the distribution of labels that the model was expecting was radically shrunk. So as new data was coming in as input to the model for inference, it was just getting ignored and replying back with like the fallback data. This was out there for months. And we got faster response times, but the model wasn't even doing anything. It was just being like, oh, I wasn't expecting this fallback case. Again, how do you detect that? Stable. This is one of my favorite ones, because this is like really common. And maybe someone will ask questions about this at the end, but this idea of stability, but this is the gist here. There's no automation or reproducible build pipeline. What this means is that the model is being trained, it has been built, trained, operated, and then new releases are happening from a scientist's their work laptop. So when it's time to deploy a new version of the model, it's the data scientist's job to do that. And what happened with this incident was that the data scientist had a workflow which was build, train the model, run the R pipeline, spit out the model, put it in a zip file, and send it somewhere to be deployed. And they selected the wrong file and sent it. So we'd put API serving code around it, and then we're like, wow, this is an image of a cat. Let's just do something else and not fail. But this is really common, that there's not this tooling in place, which we would have everywhere else with every type of software. But the result, what I'm really getting at, other than the fun story, is that this seemed really stable because we had stability code around serving this model. But as a bonus incident, can anyone guess what happened when that person left the company? Anyone? They just gave up on that part of the business. They were like, we can't reproduce this. It's kind of encased in this person's laptop. I guess we're not doing that anymore. And that's a true story. No, it's not true, lawyers. And this is my last favorite one, is an experimental code path. And we'll touch on this later when we get into feature flags and experimentation as a preview. But often there is some time when you're experimenting with different behavior inside a model that is being served, you might implement what's called like an experimental code path, which is essentially a switch. Like if this sort of parameter is met, send this user or this request down a different path. And what happened was someone had implemented the switch incorrectly, and everyone got filtered to the default fallback case, which was like the default Rex, for example. And this is really common. And it's really hard to detect because it rolls out, and probably internal people are just like used to seeing the default because you're not spending money or anything on yourself. So everything just looks completely normal. And then it takes someone else later on to maybe tweet. And this is a common thing that happened where someone will be like, yeah, people on Twitter are joking that they just bought this item, and yeah, we're still serving it to them, and you're like, oh my god, everyone's getting the defaults, which are just based on volume. So it's like, this is what I mean by a behavioral incident. Like, all this money is spent on a data science team and all this stuff putting it into production, and it just completely wasn't working. It was as though we had done nothing, and that's what's interesting to me. I'm going to skip this one, but this is essentially about ensemble models. This is where stuff gets really complicated, because you're talking about distributed systems and collections of models that speak to each other. This is a world of pain from my perspective, and none of the machine learning platforms that I've seen really deal with this really well. But yeah, so now what? Like I've just told you, everything's terrible. Like everything we've ever done to operate services is now out the window, and this is so much harder. Ramin, what are we going to do? But you know, this is actually super exciting, because it means there's all this opportunity for innovation in how we operate services. And you know, you people keep innovating and doing these wonderful things, and it provides quite a challenge for us to operate this stuff reliably. But from the world, there's a bunch of emerging ideas in the world of production engineering and SRE that are new to that world that actually apply perfectly to what we're trying to do with operational machine learning. I just want to introduce some of those to you very briefly, so we can start to think about them and use that as a vocabulary as you're now going back and, I don't know, maybe managing teams or hiring for teams and thinking about the kind of people you need to get on there to actually put stuff into production. And it's really what's happening in the production engineering space that applies perfectly here is this mindset shift from correctness to safety. And this is really subtle, because when you're faced with these incidents in the stories, probably your impulse, and definitely your impulse, is, well, let's just make sure we do way more tests up front to make sure everything's okay. But what that implies is that you're actually slowing down, being a bit more cautious. And I don't know how many of you are here. Most of you said you are practitioners, but there's probably a few of you who are business owners or executives. That's the last thing you want to hear, is that everyone wants to go a little bit slower and be a little bit more cautious. Everyone wants to go faster, try things, fail fast. So what the shift here is, like, forget about correctness. Can we bootstrap a world of safety around this so we can move fast and be better at detecting when these things go wrong and roll back? And that's the mindset shift that is happening in production engineering and is completely applicable to operational machine learning. Oh, I skipped a couple. So there's three concepts that kind of embody this to me. One is test in prod, or testing in production, progressive delivery, and then my final and favorite one is error budgets. So I'm just going to like whip through these really quickly, because I think we're close to being out of time. So testing in prod doesn't mean, and this might not apply to you, it doesn't mean just like not testing your code and rolling it out and la ha ha ha. It used to mean that, but what it means now is actually like extending the software development lifecycle beyond release. So I like to think of it of like, with the software development lifecycle, we've discovered Europe, and then we're setting things off to sail, which is releasing it, and we think it might sail or it might fall off the end of the earth. And we're now just like, testing in prod to me is like, we've now set sail and we've discovered the Americas, and there's this whole world of tooling that is like coming into existence. We're like, wow, we should be thinking about the software when it's been running. This is amazing. Why didn't anyone think of it? Well, we've thought of it now. But yeah, there's a person called Charity Majors. She has a company called Honeycomb, and they built some really interesting technology around high cardinality data. But she's really like taken this concept from like a meme and the joke about not testing your code to something that's really important and fundamental to operate as a system. But the real gist of it here, man, I'm using this laser a lot, huh? Is that you can't really verify that your software or any of your services are doing the right thing until it's really been exposed to real users, real traffic, real scale, and real unpredictabilities. That's what's important. And if you're not doing that, you basically haven't finished. You haven't finished the software. And the other side of it, really, that makes testing in prod so important, is that so many of us are operating at such high scale now that it's completely impossible to replicate enough of your production environment in like a staging environment. Like, do you imagine Facebook has like a spare copy of Facebook with 1 billion users that they can just test things out in? No, you've got to be safe about rolling things out, testing it in production, and if you put those safety harnesses in, you're going to be able to move a lot faster than saying, I just need to build a spare Facebook or a spare Amazon, and we'll try this little change. Anyway. Oh, man, I'm double. So the second is progressive delivery. Progressive delivery is like a really subtle one to grasp, but it's essentially, this is a great definition by James Governor, who's an analyst who actually coined this term, which is progressive delivery is continuous delivery with fine-grained control over the blast radius. So progressive delivery is popular. Again, thinking of the business people in the room, when you go to the enterprise and you talk about continuous delivery, everyone freaks out, There's this idea that the engineers are just changing things, the software is changing all the time, no one has any control everything. With progressive delivery, it introduces this idea of having absolute control over how continuous the release is. And there's really two fundamental concepts in progressive delivery that are completely applicable here. One is feature flags. So you've separated deploy from release, and you may roll out code, but you can, from a remote place, toggle on features for different segments of your users. So you can already start to think like that experimental code path. Oh, hang on a minute, that might not be a data scientist putting some switches in a little bit of our code here. We could actually have like an enterprise-wide feature flag system and start to toggle things on and off and see what happens, but most importantly, be able to roll it back out. The second idea is this idea of canary rollouts, and this is the most fundamental. It's this idea that instead of just deploying, seeing if it's good, and then walking away and everyone gets it, this idea of very gradually rolling out the release to a specific and targeted percentage of your user base, monitoring them across the key metrics, like conversion, maybe over a long period of time, and then you can start to say like, hey, these people that are exposed to this new recommendation engine aren't buying anything. You're like, oh, we broke it, that's why. So that's the gist there. And this, as I said, this is my favorite, error budgets. So error budgets are a kind of emerging idea in SRE, which is site reliability engineering. But it's this idea, I don't think, oh, here we go. I like this. So I'm going to tell you, your job isn't to operate infinitely reliable software. Actually, your job is to release broken software. And yeah, you should go tell your boss this tomorrow, or whatever. Well, wait, is it Friday? Yeah, on Monday when you go and say, how was the conference? Be like, I don't know, this funny guy with tattoos got up and said, I should release broken software all the time. And then you'll be able to give them this argument. But the gist of this is that, given your SLA, you might have some spare nines to play with. And this is a really subtle idea to grasp. The idea is that, you know, some clients or consumers of your service, you've given them an SLA, it might be 2 nines. If you're actually operating that service at more reliability than you've promised them, you're doing them a disservice, because they're going to build against an SLA that's greater than what you've promised them. So at some point, you might be like, okay, we actually are going to operate at our SLA, and you're going to cause an outage for them downstream. So this idea of error budgets is, if you have, for some reason, like failure has spared you, and you have this spare nines, it's actually the case, not so much the case that failure has spared you, probably more the case that you're optimizing for the wrong things. Either you've over-budgeted people to operate and work on reliability, or you're not doing enough innovation in terms of trying to try out new things or try out risky things. And that's exactly what the concept of error budgets is be very mindful of what your SLA is and what the headroom there is to experiment with. And this is where you do the experimental stuff. So the idea is that, you know, this stuff is really complicated. Data replacing code introduces this like fantastically difficult to reason about vector of complexity to your services. And you really have to experiment. You have to proactively experiment with how things behave to be able to safely operate these systems. And really, the place to do that is inside your error budget and have headroom there. So just final 2 slides. I think you have to, 2 things I want to leave you on. You have to accept that the solution to complexity is not simplicity. Simplicity is very expensive. It's not just making things simpler. You have to go beyond complexity and tear things down. And it's really just coming back to this. Once you accept that complexity is inevitable and is a symptom of success and scale, shift your mindset from correctness to safety, optimize and building tooling and things around safety, and that will allow you to align with the business to go fast, but also continue to innovate and do interesting things. And that's it. That's the gist of it. Thanks.